Hi everyone, I hope I'm audible and my screen also visible. So just send a yes in the chat if it is visible and I am audible. Okay, so hi everyone, welcome to today's PCD of the today's CodeChef, which was CodeChef Starters 182, and we'll discuss the first four problems of Division 2. But before we get started, I will tell you about all new TLE's CP31 sheet. All right. So, as you can see, um, that this sheet actually encapsulates 31 handpicked problems from each rating from 800 up to 1900, and they are carefully handpicked so that each problem teaches a unique idea. Okay, and added to that, every week on YouTube, 7 to 8 solutions will be uploaded so that you won't have to search for them. Also, there's a leaderboard right here where you can compete with your peers based on the number of solves that you have. Also, this sheet connects with your CF account directly, so you won't have to take a checkbox here manually. All right. So the link to this is down below, and let's start now. All right. So in the division two, the first problem was called bar queue. Bar queue. Chef is throwing a grand party at a bar. There is already a queue at the entrance, waiting for the event to start. The queue can be represented as a string S of n characters, either B or G. The first character of the string represents the front of the queue. The entry gate security allows people to enter one by one from the front of the queue, but as soon as the number of boys who have already entered the bar exceeds twice the number of girls, the security closes the entrance. Determine the number of people in the queue who are allowed to enter the bar. Okay, so this was the problem, that simply you have a string of B's and G's, right? So let's say you have a G, B, and something like this. So you have this string, and this is the front of the queue, right? So first this girl will go inside, then this boy will go inside, then this girl will go inside, and they will keep going until the number of boys inside, let that be B, it is while it is strictly less than or equal to 2G. Okay, then they will keep going inside. And initially, if you see, initially they have 0 and 0, right? So therefore B is less than or equal to 2G satisfied. So they will not start, they will not stop at the starting only, right? Because initially this condition is satisfied, so they will start, and while this is true, they will keep entering into the bar or the restaurant, and as soon as this is not true, that is b becomes greater than 2G, it will stop. So we have to just count the number of people who will enter the bar, and it is pretty simple. Like, they have told you what to do, you just have to do it, right? Like, just iterate over this string, from left to right, and keep a count that how many boys and girls there are in the bar, right? Currently, and if this condition happens, then just break, and if it doesn't happen at all, then the answer is n. Like, when the queue becomes empty, or this condition is there, you will stop entering the people in the bar, right? And at that point, how many are there, you will just report that. So that is pretty simple to implement, I think. Like, this is just implementation, so I'll just show the code. Okay, so the code is like int t c in t, while t minus minus, int n c in n, string s c in s. Okay, Now I have these two counters. That is the number of boys and number of girls. And flag equals to false. Like flag is just that if I encounter b greater than 2g at any point, then I just print I plus 1, the current I plus 1, and flag equals to true and break. So that I will know that if flag is false, then that means I did not break due to this condition, and like this for loop ended naturally. So in that case, I would have to print n. Right? What I'm doing is simply iterating over this string. If s of I is b, if current letter is b, then b plus plus, otherwise g plus plus. So basically, I just entered that last person, and if at this point the counter gets increased to 2g, then we'll just print this index, and if we did not print any index, then in the end we will print n. Okay, so this is the logic of my code, or the code of my logic, or this is my logic and my code. So whatever you want to understand, like, this is the thing. So do you guys get it? Anuj Mishra, just one doubt in string input problems. Last test case waits for one enter or new line before printing the last result. uh Anuj, what are you asking? I can't understand. Like, in which language do you code? So in C++, if you just take the int and scene and string s scene s, then you don't have to worry about the enters and spaces. Like, this string s scene s takes the scene up till wherever it finds the first white space. That is a space, a tab, or a new line. Okay. Minimizing the sum. Like, I haven't solved that problem in the contest, so I won't be able to discuss it right now. But you can look at the editorial. Like, if you are trying to absolve um, this much, then I think you should be able to understand from the solution also, which is like the editorial. All right. So if this problem is done, then I'll move on to the next one. Okay. So, beautiful garden. Chef has a beautiful garden that contains n flowers. Initially, all the flowers are in a full bloom. However, each flower is a bit shy. Once plugged, the ith flower takes ith days to regrow and bloom again. Chef loves plugging flowers, but also wants his garden to always look beautiful. For this reason, he insists that there are always at least k flowers blooming in the garden at any given time. Over a period of d days, numbered from 1 to d, Chef will pluck some of the blooming flowers. On any day, he can choose to pluck any number of blooming flowers as long as, after plucking, there remain at least k blooming flowers. Note that if the ith flower is plucked on the day x, it will regrow and be available again only on day x plus ti. The same flower may be plucked multiple times, provided that it has regrown after a previous pluck. Determine the maximum total number of times chef can pluck a flower D. Chef will pluck a flower in D days while respecting the garden's beauty requirement. Okay, so yeah, the problem says that you have like n flowers. Okay, you have a garden and you have n flowers there. So let's say this is one flower. Uh, let's assume it is a flower. Okay, right. So you have like n flowers, right? You get the point. And it's like when you pluck a flower, initially all of the flowers are there. Okay, but when you pluck a flower, when you pluck a flower, what happens is that it gets plugged, right? There is no flower there no longer, but it will regrow. It will regrow, and after ti amount of days, like if you pluck the is flower, then after ti amount of days it will regrow again. So it will be there again for you to pluck, right? And at any point in time, you want that there must be at least k flowers in your garden, right? So respecting this constraint, the problem is asking that in the first d days, in the first d days, how many total number of flowers can you pluck, right? So that is the problem here. So let's look at the samples. Okay, so for example, we have 323 and 112. So 3, so 3 to 3 is n is 3, our k is 2. That means we have to have at least 2 flowers at any given point in time, and d is equal to 3. So we have 3 days to pluck the flowers, and the regrowth period is what? Regrowth period is 1, 1 and 2, right? So basically, the first flower will regrow the next day. Same for this one, and the third flower will take 2 days to regrow, right? So now, okay, on the first day, suppose it is now the first day. So what will you do? On the day one, on the day one, you will basically plug this flower. Like you have three options, right? Either you can plug this or plug this or plug this. Like because you want that two flowers must remain there. So you can pluck only one of them. So out of two options, um, that either you can pluck the flower with regrowth period as 1, or you can pluck the flower with regrowth period 2. So which one should you pluck? Tell me, guys, which one would you pluck? You want to maximize the total number of flowers that you have plucked over the d days. Least one. Yes, exactly. So um, you will simply choose the one which will take the least amount of time to regrow, right? Because there is no point in choosing uh, a flower which takes more time to regrow, because it, in that case, it will available like after, like in the first case, let's say you delete it from the, in the first day you delete this. So I'll mark it a blank here because we don't have a flower there, and this is 1, this is 2. Now at d equal to 2, basically this flower has reappeared. Okay, so 112. But if in case you had plugged this flower, then it would have not reappeared on the second day. So I think it is pretty obvious that you should always pluck the least one, like the one with the least regrowth time, so that it can regrow as fast as possible, and we can pluck it again if we want, right? So at d1, we'll pluck this flower, so it will be gone. But on at second day it will reappear, so we have 112 again. So again we will pluck this flower, and it will be gone. So here dash will come, so we have plucked two flowers, and now at d equal to 3 again it will come again. So 112 we have, and we can delete this again. So in total we have deleted 3 flowers. So the answer to this is 3, right? So basically you just, the greedy approach here is, the greedy approach is that delete flowers with um, least regrowth period, or basically least ti, right? Least ti. And basically that what you want is that after each day, at least k flowers should remain, right? Like here k was 2, so you only deleted 1, correct? So simply just just do it, like let's say on the first day there will be n flowers, right? So out of those, just delete n minus k, like except for the k, like the last k ones, just remove the first n minus k ones by like their time, like simply sort by their time. That is, just remove the first n minus k ones having the least ti value, okay, and then k would remain, because there is no point in not deleting. Like at, let's say on day 1, if you were allowed to delete all three of these, like let's say k was equal to 0, okay, so if you are allowed to delete all three of these, then there is no point in not deleting them. Like since you want to maximize, no, you want to maximize the total number of flowers that you delete, so um, you can simply delete all of them since k equal to 0. So but if some k is there, if some limit is there, um, which you have to respect, then just delete n minus k flowers from that, right? On day 1, on day 1 just delete n minus k flowers on that. Then what will happen on day 2? At the end of day 1, basically we were left with k flowers, right? We were left with k flowers. But okay, on now day 2, what will happen is some k plus x flowers will be there, where y plus x, because those flowers who had a period of 1, they will regrow by day 2. So now just delete x, like delete x more flowers which I have the small amount of, which have the least ti. So at each day just keep doing this. At each day just delete all of the flowers except for k, which have the lowest ti value, and just implement this. And since the value of d also is very small, like since d is up to 10 only, d is up to 10 and k is up to n and ti are up to 10, so like actually what you can do is you can iterate over the days. You can do that in day 1 I'll do this, day 2 I'll do this, day 3 I'll do this. So this will basically be solved in o of d, and you can basically maintain a set. What I did was I just maintained a multi set which will store that currently what are my flowers which are alive, like what are their ti values which are alive, right? So at every point this multiset will have at least k at least k elements, okay. And also I have another multiset called q, okay, which will contain a pair. Like this multiset is a pair, like multiset of pair, okay, multiset of pair of int command basically, where it stores that the first index stores, okay, so it stores all of the flowers which have been deleted, okay. So let's say that initially I had this 112, right? So initially this 112 would be a part of my k vector, or not k vector, whatever the name of this is, let's say s. So this 112 would be a part of my s multiset. And when I delete 2, let's say I delete 2, of course it is not good to delete 2, but let's say I delete 2, let's say I delete 2, then what will I do? let, I'll delete this, I'll erase this 2 also from this multiset, and I'll insert this 2 into the queue. So basically, this queue stores that what are the elements which have been deleted but which will regrow. So what I'll store is I'll store a pair. Okay, I'll store a pair where the first element will store that on which day will it come back. Okay, so let's say currently I am at day 1, right? And if I delete 2, then that means that on day 3 this 2 will come back. So I'll store 3 comma 2, like the first one will store that when will I come back, and this second one will store that what is the value of ti for that. And as I am iterating, I'll just check that if in this multiset, if there are, like, see, if I am iterating and there are some flowers in this queue which are supposed to be regrown by today, then I will just remove them from queue and insert them into this s multiset. Okay, so that's how I will implement. Like, this was just the implementation. The logic was pretty easy, that you have to delete all of the elements, like not all of the elements, you have to delete all the flowers but k, and delete the ones which have the smallest value of ti, and just do this at every step, and keep track of what flowers are there which have been deleted, and what are there which are going to be regenerated, and when are they going to be regenerated. Okay, so just give a multiset for that. So since this is implementation only, I'll again just show the implementation first, and then I'll take your doubts. Okay, so I have this multiset t. So nkd, c in nkd, multiset t for int I equal to 0, I less than I plus plus, int x, c in x, t dot insert x. Okay, so I am just taking input in directly multiset. I am not taking the array. I am directly taking the input in a multiset. Then I make this multiset of pair, which is called q. Okay, and count equals to 0. This count is my answer, that how many I deleted. Okay, so for int I equal to 0, I less than n, I less than d, I plus plus. So I am iterating over the days. There are total d days, right? So what I am doing is, in the first while loop, whatever elements there are in the multiset q which have the first element, like q dot first, the element dot first is I. If element dot first is I, then that means that that element, it was supposed to be regenerated at the ith day. So while q dot size and q dot begin dot first equals to I, then I will insert that into t. T dot insert q dot begin dot second, and q dot erase q dot begin. So I am transferring that element from s into t. Okay, so that's what this while loop does. And while t dot size is greater than k, so I am deleting all elements but k elements and the smaller ones, since the multiset stores the elements in a sorted order, right? It stores it in a sorted order. So what I can just do is iterate from the begin. Like, what I am doing is, while size of t is greater than k, count plus plus, because I'm deleting one, and I'll insert into q I plus star t dot begin, comma star t dot begin. And what is the star t dot begin? It will basically tell me that, okay, what is the smallest t that is in our multiset, right? So I'll just delete that. So since I'm deleting that, the second is this, like the second element of the pair is this, and the first element of the pair is I plus star t dot begin, which is the current day plus the time of regeneration. So this is the day at which I want to again include this into my multiset. So I am inserting it into q, and yeah, and also erasing it from t. So this will happen for d days, and finally I'll just print my count. Okay, yeah. So if someone has a doubt in this, then they can ask right now. So do you have a doubt, anyone? Clear. Okay. So I'll explain the third problem now. The third one is palindromic score. Alice has three types of characters, A, B, and C. So she is given exactly x copies of A, y copies of B, and z copies of C. Alice must use all of these characters to form a string. She is free to arrange the characters in any order of her choosing. After Alice forms her string, Bob makes a move. Bob will choose one character type from A, B, and C and delete all its occurrences from the string. Alice's final score is defined as the length of the longest palindromic subsequence of the string after Bob's deletion. Both players play optimally. Alice's goal is to rearrange the characters to maximize her final score, and Bob's goal to choose a character to delete such that Alice's score is minimized. Determine the maximum achievable score that Alice can obtain through her optimal arrangement of the characters. Okay, so simply we have three characters. Okay, A, B, and C. Right. So Alice has given X copies of A, Y copies of B, and Z copies of C. Right. And she can arrange these characters in any way. Okay. So let's say she arranges something like this. Let's say value of X is 2, Y is 3, and Z is 2. So there are two A's. So let's say she arranges it like something like this: A, B, C, B, C, B. Right. This is one proper arrangement. Okay. Now, um, now what will Bob do? Like this is Alice's move. Alice's move is this, that she will arrange these characters into a string. Right. Now what will Bob do? Bob will choose a character. Okay. Bob will choose a character and delete all of the occurrences of that character. So let's say if Bob chooses C, then this would become the string. But let's say Bob chooses A, then this would become, and so on. So that's what Bob will do. And after this, let's say Bob chose C. Okay, so the final string is what? The final string is A, B, B, B. Right. So this is the final string, and Alice's score. Alice's score is defined by the longest palindromic subsequence of the string S. This final string S. So the score is defined as the longest palindromic subsequence of the string S. That is Alice's score. Okay. So what does it mean? Let's say for this string. So I think you would all know what is palindrome, right? And what is the subsequence? So I think both all of you know these two terms. So a subsequence, which is a palindrome, is called this PS, right? And the longest one of them is called the LPS. So the length of the longest, sorry, the length of the longest S, the length of the longest LPS of S is my Alice score. So let's say S is this, right? So what's the score here? What's the score here? Um, let's see. So I think the longest one is this only, B, B, and B, which is palindrome. So that's why this score is equal to 3. Okay. So yeah, that is the problem. And basically, given x, y, and z, we have to print the maximum score that Alice can achieve by rearranging the letters optimally. Like basically, what Bob will do is that he will delete that letter, which results in the score being minimized. Like here, Alice made the string this one, right? Alice made A, B, C, B, C, B. So let's say Bob had deleted A also. Like let's say Bob had deleted A, right? Then it would become B, C, B, C, B, right? But so the score of this string is 5, because you can take the entire string and it is a palindrome, right? So the score of this string is 5. But since Bob deleted the C, so it became AABBB. So that's why the score is 3. But okay, but what if had deleted B also? Like Bob can delete B also, right? So if Bob had deleted B, then the string would become what? AACC. So the score of this one is even lower. The score of this is 2, right? So definitely Bob will delete B. Bob will delete B because he wants to minimize the score of Alice. So essentially, if Alice rearranges the string like this, then she will get the score of 2 because Bob will remove B. So out of all the possible rearrangements, what is the maximum score that Alice can achieve? That is the problem, right? So essentially, we have to construct one, right? We have to construct a sequence for which it is maximum. The score is maximum. So okay, let's have a look at the input, the sample input. So we have three zero zeros. That means we have three A's. A. So we have only one way to rearrange this. That is A. And what will Bob do? Bob will just delete A's. Like Bob will just delete all of the A's. So it will become the empty string. So for empty string, the score is 0, right? So therefore, the answer to this is 0. Okay. Then we have 430. Like we have four A's, A, and B, right? So let's say we do this. We just keep them like this: A, B. So if Bob deletes all the C's, let's say if Bob delete all the C's, then score will be 4 because of this A. But if Bob deletes all of the B's, then score will be 4 because of this A. But if Bob deletes all of the A's, then score is 3. So B. So therefore Bob will delete all of the A's and score will be 3. Okay. And then we have 2, which is A, B, C. Right. So if we rearrange this smartly, okay, so how should we rearrange this? Just think about this. Like, let's say I rearrange this as something like this: CA, BB, AC. Okay. So now whatever Bob deletes, okay, whatever Bob deletes, let's say he deletes C. Then ABBA, it is a palindrome, so score is 4. Let's say Bob deletes A. So CBBC, it is a palindrome, right? And let if Bob deletes B, then CAAC, it is a palindrome. So whatever Bob deletes, the score is 4. So therefore the answer is 4. So yeah, how do we construct a string in such a way that the score is maximized? So first of all, think about what will happen after deletion. Like after deletion, we are trying to find the length of longest palindromic subsequence of the string, right? So okay, when Bob deletes a character, like initially the string had A, B, and C. Initially string has only A, B, and C, and then Bob deletes a character. Suppose Bob deletes one character, so we are left with two characters, right? Whose occurrences are X and Y, and we are trying to find the longest palindromic subsequence of that final string having X A's and Y B's. Okay, so just think about that for 1 minute. That what is the highest value of that LCP that you can get using X and Y? Like for example, if I give you four A's and four B's, so how will you construct a string in such a way so as to maximize the LCP of this string? Like how will you construct this? Can you guys tell me that how will you construct a string using four A's and four B's such that its LCP is maximum? So yeah, just tell me guys. just alternate. So but if I alternate, then it will a b a b a b a b. So this will have LCP of 7, right? This substring or this subsequence has is a palindrome, and it has length 7, and the entire one is not a palindrome. So what you gave has LCP of 7, but you can do better. Like you can also get an LCP of 8. So tell me that what is the string which will give me an LCP of 8, which has 4 A's and 4 B's. AA 4B AA, yes, exactly. So AA, then BB BB, and AA. So this is the string which will give me an LCP of 8, right? So what can I say? That if I have X characters of A and Y characters of B, then I can make an LCP of X plus Y. You might think this, like the length of string is X plus Y, right? The length of string is X plus Y, and we are able to make X plus Y as LCP, right? So basically we are able to make the entire string as a palindrome. So therefore the answer to LCP is X plus Y. That's what you might think, but this is wrong. Why it is wrong? Actually it is wrong in that case where A and B are both odd. Okay, so let's say we had um, A as 3 and B as 3, like A as 3 and B as, so we basically we have 3 A's and 3 B's. So you will get a 6 length string, but in this case you cannot get an LCP of 6. Like you cannot make the entire string a palindrome, right? Because in a palindromic string, at most one character frequency is odd. At most one frequency is odd. The character of one frequency of one character is odd. But here the frequency of two characters are odd. So therefore you cannot make a palindrome using this. So what you just do is make a 5 length. Make a 5 length subsequence. And how will you do that? You can simply um, something like this, like AB, then BA and AB. Okay, so here you will have ABABA, right? So this is the 5 length LCP, sorry, LCP, longest LPS, LPS, which you will get. So if both are odd, like if both X and Y are odd, then the longest LPS that you can get is X plus Y minus 1. And if at least one of them is even, then you can definitely get X plus Y. Like let's say one is even and one is odd. Like let's say A is 4 or A is 4, let's say, and B is 3. Then what will you do? You will simply keep this A, B, 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 and A, right? So this will give LCP of X plus Y. So if X and Y both are odd, then you can at most get X plus Y minus 1. And if X and Y, like otherwise you can get X plus Y as your LPS. Okay, so after deletion we just saw that what can happen, right? This can happen that if we are left with X characters of one occurrence, X occurrence of one character and Y occurrence of the other character, then if they both are odd, then we can at most get X plus Y minus 1, and otherwise we can get X plus Y. But now our job is to construct a string, right? We have to construct a string which satisfies these conditions. Like these, like see what I just proved was that we can create, like if we are just given characters of two types, if we are given X characters of A and Y characters of B, then I can make X plus Y if X and X or Y is even, and I can make x plus y minus 1 if x and y both are odd. But now actually what I have been given is three characters a, b, and c with frequency of x, y, and z. And what I have to make is that, what do I have to make? Just think about this for a minute. What I have to make is a string which upon deletion of any character, like if I delete this a, then this should be y plus z. The remaining string should have lps of y plus z or y plus z minus 1, whatever. So if I delete a, then the remaining b and c should form a string. Then if I delete this b, then the remaining a's and c's should also form maximal lps. And if I delete this c, then the remaining a and b should also form maximum lps, right? So what can I do to do that? Like how will I construct a string like that? So I'll just tell you guys the string, what the string is. Okay. So actually what I constructed was that, let's say this is x, this is y, this is z. So just keep x by 2, like the floor of x by 2 is, like just keep a. Okay, these are all a's and they are x by 2 a's. Then just keep b's, like half the b's, just keep. So y by 2 b's you just keep, and then just keep all the c's. So z by 2 c's you keep, right? Then in between what will you keep? You will keep a, b, and c if they are odd. Like whoever's frequency is odd, you will keep that. Like if a's frequency is odd, then you will keep one a here. If b's frequency is odd, then you will keep one b here. And if c's frequency is odd, then you will keep one c here. So let's say if frequency of b and c both are odd, then you will keep bc here. Okay. And then again you will just do c c c c c. Then you will do b b b b b, and then you will do a. So this is also half times z by 2, y by 2, and x by 2. So basically this final string Alice can make this final string. And what will happen is that whatever Bob deletes, it doesn't matter. Like we will always get a maximal lps. Okay, like if Bob deletes a, for example, then these a would be deleted and these a would be deleted. So what we will get is these b are with these b, like a palindrome. Then these c's are with these c's, palindrome. And if a b is there, then one b will be there, or one c will be there. So basically it will have x plus y minus 1 if both b and c are odd. So yeah, it works out. This is the construction. This is the construction that I have given you. That first the half a's, then half b's, half c's, then whatever are odd, and then again half c's, half b's, half a's. Okay, so that's the solution here. We can construct this, and the score of this will be the maximum. Like we'll just check that if Bob deletes a. Okay. If Bob deletes A, then the score would be y plus z or minus 1. Like if both are odd, then minus 1. If Bob deletes B, then the score would be x plus z. And if Bob deletes C, then the score would be x plus y. So whatever is the minimum of this, Bob will delete that, right? Bob will delete that so that the minimum of all of these values will occur. So our final answer is just the minimum of all of these three. Okay. So if we are given x, y, and z, so our final answer would be just the minimum of those three values. Which three values? Basically, just take two pairwise and calculate x plus y or x plus y minus 1, depending on whether they are both odd or not. Anyways, so this is what you can do. So is it clear, everyone? Like, is the construction clear, that what I have constructed and why it is correct, and why it gives the value, these values, why it gives? So is it clear, guys? If you have a doubt, then you can ask right now. Okay, so I'm assuming there are no doubts. So I'll just show the code. Okay, so xyz, c in xyz, ans is equal to max. Like, what I'm doing is ans equals to min of ans comma. Let if Bob deletes c. This is the first case if Bob deletes c. So the answer is x plus y minus odd and odd. So basically x and 1. Doing x and 1 just checks. Like x and 1 is 1 if x is odd, and 0 if x is even, right? I am just taking bitwise and with 1. So if x is 1, then this would be true, or this would be 1. And if y is true, like if y is odd, then this would be 1. So I am taking the logical and. So this will return true or false. So if it returns true, then minus 1 will happen. And if it returns false, then minus 0 would happen. So nothing would happen. So I'll take the minimum of all of these three values. X plus y minus this expression, y plus z minus the y and z are odd, and x plus z minus x and z are odd. And I'll just print the minimum value of out of all these three. Yes. Okay. So I think it should be clear. I'll move on to the last problem of today. Okay. So we have MasterChef. Chef has recently started conducting a master class where he teaches his disciples world class recipes. There are n students in his class standing in a line represented by a string s of length n. Each character in S is either B, a boy, or G, a girl. Chef has an annoyance factor of K. He gets annoyed and refuses to teach if and only if there are at least K consecutive disciples of the same gender in the lineup. You are allowed to perform at most one operation. In a single operation, you may reverse any substring of S. Any substring of S. Determine whether it is possible to perform at most one such operation to obtain a string in which chef does not get annoyed. So he ends up teaching his disciples. And they have given what is substring. Okay. So yeah, this problem says that there are some boys, there are some girls in the line. So it is quite similar to the first problem, but here they are going to a cooking class instead of a bar. So their life has somewhat sorted now. But anyways, so there are some boys and some girls. So G B B B G G B. Let's say this is a string, okay, and there is a number K. Let's say it is 2, or let's say it is 3. Okay. So if K is 3 and S is this, then the chef will get annoyed. Why he will get annoyed? Because there are at least 3 students of the same gender in a lineup, right? So that's why he'll get annoyed and he won't teach the class. Okay. So that is one thing. And to ensure that he doesn't get annoyed, we can do an operation. And what is the operation? We can simply choose any substring and reverse it. Okay. So let's say I reverse this substring right here. Let's say I reverse this substring BGG. So what would the string become? It would become G B B uh, GG BB, right? So this substring I reversed, and in the final string, as you can see, there are no blocks of K or more. Like there are no blocks of size 3 or more. All of the blocks are only of size 1 or 2, right? So that's what you can do to make sure that the chef is not annoyed. So in one operation you can do this, and you are only allowed to do one operation. So in this case you will print yes. That is the problem right here, that you have to print yes or no, that in at most one operation is it possible to ensure that the chef is not annoyed. Okay, so the samples, let's say, uh, we have VG, BG, BGB. This is yes because already K is 2, so there are no blocks of size at least 2, right? Then we have GGB. So what you can do is just reverse this GB. Okay, then you have 4 B's and 4 G's, and you have like the annoyance factor as 3. So what you can do is just reverse this substring. Okay, so that will cause that BB, GG, BB, and GG. So in that case, you will have less than 3 everywhere, and this 4, 2, and GGGB. So it is not possible to partition this. Okay, and also in this one, also it is not possible. And in the last one, we have BBBBG and BBBG. So the problematic one is this one, right? These 4 B's are problematic. So what we can do is just reverse this substring. So that will break these 4 B's technically. That will break these 4 B's if we reverse this substring. And the answer is yes. Okay. So yeah, how to solve this? Now actually, just think about what does reversing the substring do to the like components. Like see, let's say I break my string into components. Like let's say my string s is something like bg wait, bg gb gbb ggg. So here the components are what? This b is one component, this gg is one component, this b is one component, g is one component, bb is one component, and ggg is one component, right? So when you reverse a substring, suppose you reverse a substring, so what will happen? Like let's say you will place two partitions. Like let's say you place one partition here and one partition here, and you reverse this substring. All right. Then actually the components don't change. Like they merely change their order. Only their order is changed, but their lengths are not changed. Like in this case, this subarray will be reversed, right? This subarray will be reversed. So what will happen is this component of B will be there. Then this component of GG will still remain GG, but it will go ahead like this. And this B will remain here, and this G component will remain here. So it will come to the first. And then we have these three B's, and we have these three G's. So the components are still the same. In our string, the components are still the same because we chose the partition between the components, right? So choosing them between the components has no purpose at all. Like because if initially the size of any of these components was greater than k, like the maximum size is 3, right? So if k is 1, 2, or 3, then chef will get annoyed using this string. And in this one also he'll get annoyed because here also the components are same, like their maximum size is same. We are not able to break them at all, right? Because we kept the partitions in between the segments, right? But what if we don't keep them between segments? Like we keep them to cut the segments. Like, let's say I cut this, let's say I cut this one, and I cut this one right here, right? So now if I reverse this substring, if I reverse this substring, then what will happen? Let's see. So basically what will happen is that B G B, and then this G gets cut, and since I'm reversing it, so BB will come here, and G will come here, and B will come here, and then we have GGG. So as you can see that since I made the partition pass through these two components right here, right here, so therefore these components actually broke up. So this component broke up into two, this one and this one, and this component also broke up into two, this and this. So actually the thing is that when you place the two partitions, whichever components you place them in, like whichever components they cut, only those components can be split. Okay, so my claim is that when you keep a partition, let's keep a new string, or let's rewrite this bgb gg bbb and ggg. So my claim is that, wait, yeah, so these are the components. So my claim is that when you put a partition through a component, then only that component can be split. Like, it may be splitted, there is not even guarantee that it will split. Like, for example, if I pass through these partitions through this both g's, okay, like if I do this, if I take this subarray and I reverse it, then what will happen? Nothing will happen. Like, because this string actually is a palindrome, G B B B B G. So reversing it doesn't make anything. But let's say I do this. Let's say I do this one. So here, if I reverse this, what will happen? It's just that the size of this component will increase, and the size of this will decrease. Okay. So it is not even necessary that that component breaks up. So what I'm trying to say is that only those components where you place a partition, only those components where you place a partition, only they are possible to break. Like, other components definitely are will not be broken. So let's say I have three components. So okay, let's say I have k equal to 3, and I have this string b b g b b b b g g g and b b b, right? So I have this bb, then I have this g, I have these four b's, I have these three g's, and I have these three b's, right? So now what are the components which are problematic? That is, which components ko dekh ke, like, by after seeing which components, chef will get annoyed. Basically these three, right? After seeing these three components, chef will get annoyed because they are greater than equal to 3, correct? But the thing is that we can only break a component if we are placing a partition into it. If we place a partition into a component, then only we can break it. And the thing is that we can only place two partitions. We can only place two partitions. So actually we can never break three components. We can never break three components, or even more than three components if we have, then we can never break them. So the first thing that I'm saying is that if we have more than three problematic components, or greater than equal to three problematic components, Then the answer is no. The answer is no, because we will not be able to break all of them. Okay. So greater than 3 we have sorted. Let's say we have 0. If we have number of components which are problematic equal to 0, then the answer is yes. Answer is yes, because already the string is not annoying to the chef, because the number of problematic components are 0, right? So now the cases which are left are 1 and 2. Like either it could be 0 or it could be more than 3, but or it could be 1 and 2. So the number of components, the problematic components is equal to 2, or problematic components is equal to 1. So in these cases what will happen? Let's see. Actually, even this case is pretty straightforward. Why am I saying that? Let's see. So let's take an example of this. So let's say I have k equals to 3, and I have b b g g b b g g g, and then I have, let's say, b g b. Okay. So the components here are what? b b b g g b b g g g, and I have b, and I have g, I have b. Right. So the problematic components are what? This one and this one, right? So since they are problematic, so definitely I will have to pass a partition through them, right? I will have to pass a partition through them, and if I do that, then what will happen? Let's see. So let's say I place a partition through them. So I put a partition here, let's say, and I put a partition here. Okay. So as you can see that in between whatever components are there, nothing will happen to their size. Okay, like this gg will remain gg and this bb will remain bb. It might happen that gg comes after this bb, the order might change, but the components will remain the same, right? But just that these two components will get broken. Okay, so what will happen is that this b will go here, and it will, okay, I'll just show you. All right, so what will happen finally is bb, then we have a g, then I will have a bb and a gg, and I'll have a b, right? Then whatever was remaining, a gg, then a bgb. Okay, so essentially these two g's, sorry, like these two g components were initially the same, and these two were same, but now we are able to we are able to break them by partitioning them at the correct position, right? So that's what we can do here. But okay, how do we know, like, what is the condition in which we will be able to break them? Like, will we always be able to break them? The answer is no. And why is the answer no? I'll tell you that. See, I'll give an example. Okay, so let's say k is 2. K is 2, and we have, like, suppose we have two components, b b b b b and g g g g g. Sorry. So we have these two components. So um, they are problematic, right? They both are problematic. So what we can do is that we'll try to partition them. But no matter how we partition them, let's say we partition it like this, then also, like, these three b's will be there, or these three g's will be there, but we want at most two, or in fact we can just take, I can just take three also. Let's say we have three b's and I have three g's. Okay, so even if we partition it anyway, like let's say here to here, then then also these two b's will always be together, and these two g's will be together. So actually there is no way to partition this into two. Okay, because like you cannot make 3 as a sum of two numbers which are less than 2. Like you cannot express 3 as, see, these three b's are there, right? So you cannot break them into x plus y, where x is less than 1, x is less than 2, and y is less than 2. That is not possible, right? So that's why if your k is 2, then at max you can break a 2 length component. Okay, and in general, if I say, in general, if your k is some k, then you can only break at max 2k minus 2 length. Okay, you can break it into k minus 1 and k minus 1. All right. So if any component has length greater than that, if any component has length greater than or equal to 2k minus 1, then the answer is no. Okay, because you cannot break them. So this is one case right here. So okay, I'll summarize till now that if we have more than 3 components which have size greater than or equal to k, then the answer is no. If we have no components which have size greater than or equal to k, then the answer is yes. Then if we have 2 components, then we are just exploring that case. If we have 2 components, so we have to place the two partitions into in those components. But if either two of those have greater than or equal to 2k minus 1 elements, then the answer is no. Okay, but what if both of them have less than 2k minus 1 elements? Like both of them have at most 2k minus 2 elements, then is the answer yes? Is the answer yes? The answer is not always. Okay, why not always? Because actually it might happen that they are in the same category. Like it might also happen that, see, uh, let's say k is my let's say 3. Okay, and you have a bbb, then you have a gg, and then you have a bbb. So let you have to partition these two b components, right? So what will you do? Let's say you place here and here, then that will cause that here 4 b's will come and here 2 b's will come. So finally the output would be bb, bb, and gg, and bb, bb. So what I am saying is that if you keep the partition in the same type of the letter, that is either both b's or both g's, then actually the component won't break, but rather the number of elements will be distributed. Like initially there were three elements in both, right? There were 3 elements in both, but now there will be 4 and 2. Sorry, my bad. 4 and 2 elements. So basically if you, so my point is that if you keep partition in different type of component, in different type of component, then they will break. Like this 3 will break into 1 and 2, and this 3 will break into 1 and 2. But if you keep them in the same type of, letter, then merely the size will change. Like um, these 3 b's will become 4 b's, and these 3 b's will become 2 b's. Okay, so essentially, so basically what you are doing is bringing these 2 b's here and bringing this 1 b there. So therefore finally there are 4 b's right here and 2 b's right here. So my point is that if you have two components which have size greater than or equal to k, okay, and they have same size, and they have like sorry same type, then you cannot do anything, right? Like let's say x1 is size of the first one which is greater than or equal to k, and x2 is size of the second one which is greater than or equal to k. then what you can merely do is shuffle the elements between these two components. Like you can you can just partition, kind of like you can change the partitioning. Like the total x1 plus x2 characters are there, so you can distribute them in any way you want. Like maybe you can give them as 1 and x1 plus x2 minus 1. Okay, so by doing the operation in the same type of the letter, then only the letters will get shuffled. Like if here I give an example from here, like if I have b b b, then I have g g, then I have b b b. So here these are 3 and 3, right? These are 3 and 3. So actually with my reversal power, I can actually make this 6 0 5 1 4 2 3 3 2 4 1 5 or 0 6. Like with my reversal power, I can make any one of them. Okay, like let's say you ask me that how do you make 5 1, how do you make 5 1, then I'll tell you that just simply reverse this sub-array. Okay, so you will get 5 1. So my claim is that you can make all of these by simply doing a operation on the same type of b, on the same type of letter. But the thing is, none of these are to our favor. Like if k is equal to 3, then in none of these pairs, both of them are less than 3. So therefore it is not possible. Finally the conclusion is that it is not possible, because initially this both x1 and x2, x1 is greater than k and x2 is greater than k, greater than equal to, I mean. So of course if you partition x1 plus x2 in any way you like, one of them will be definitely greater than equal to k, right? It is not possible that both of them are less than k, right? So that's why it is not possible if they are of the same type. So summarizing, that if we have basically the third case, right? It was the third case. Yeah, the third case where the problematic components are two. Like the third case was if we have two problematic components, then the answer is yes if they have opposite sign, like opposite type. Like one component is of b and the others of g, and both both size, like size of both is less than 2, less than equal to 2 into k minus 2. Size of both is less than 2 into k minus 2. If both they are of opposite type and size of both is less than 2 into k minus 2, then the answer is yes. Otherwise the answer is no. Okay, so this was the case where we have exactly two problematic components. And what about the last case? The last case is we have only one problematic component. Okay, so actually this is a very tricky case. Like there are many cases that we have to handle right here. All right, so yeah, first of all, the thing is again that the size of that component has to be what, less than equal to, size has to be less than or equal to 2 into k minus 2. So if size is greater than 2 into k minus 2, or what I can say is if size is greater than equal to 2 into k minus 1, then the answer is no. Like that one component whose size is greater than k, if that component size is also greater than equal to 2 into k minus 1, then the answer is no, because we cannot split it into two partitions having size less than k minus 1, right? Now what we shall do, now basically we have a component of size, let's say something, and this one is problematic. And let's say there are some things right here, right here, Then we have some b's also right here. Okay, value of k is 3, let's say, or value of k is 4. Okay, so what we can do is we can simply break this into two parts right here. Like one partition will be right here, one partition will be right here, but what about the other partition? Like how do we, where do we keep the other partition so that it works out? Okay, so what if we keep it right here? If we keep it right here, then what will happen, that these three b's and these two b's, they will merge and they will form a component of 5. So that is not possible. So that's why the other partition has to be in this one. Okay, like if you just do that, then these two g's will separate and these two components of b's will also separate, right? So just look for a component of g's whose size is greater than 1. Like you cannot do this with size of 1g, right? If the size of g component is 1, then you cannot do this. You cannot split this into two parts. So just look for a component of g whose size is greater than 1, and split that and split these b's. And since the length of this is less than or equal to 2k minus 2, it can be split. Like if it is greater, then we'll just say no. If it is smaller, then it can be split if there is some g which are multiple, right? So in that case, the answer would be yes. But can will the otherwise will the answer be no? Like otherwise, can we do this? Actually, yes. Sometimes we can do that. Like sometimes we'll be able to break this also. So see, what I want to say is that, okay, let's say I have a g. Let's say I have all single g's. Like I don't have any double g. I have only single g's. So um, what I can say is that, okay, let's say k is equal to um, 4. Okay, so up to 3, it is fine. So I have, let's say, 5 b's, and I have a g, and I have let's say a bb. Let's say I have a g, and then let's say I have a b, a single b, right? So here the problematic component is this one, right? We want to split this, but what we can do, we cannot split any g's. We don't have any g's with multiple number of multiple number of g's, right? There are no components with multiple g's, so we cannot split a g in half, of course. So now what do we do? Now remember the thing. Just remember this part where I told you that if you um, if you make a partition in both same type, like if you make partition in same type, you can simply reshuffle the number of characters in the component of b's. Like here you have 3 and 3, right? Here you have 3 and 3. You can actually shuffle them as you like. You can make it 6-0, you can make it 5-1, you can make it 4-2, you can make it 3-3, and so on. You can make it anything what that you want, as long as sum is the same. Like if for that, you just have to partition into the b. So actually you can use that fact right here now. Like what you can do is, you need to make this component less than 4, right? So to do that, you can use this component, right? So this component has size 1, this component has size 1, and this component has size of 5. So together their size is 6, right? Their size is 6. So what you can do is, you can reshuffle them and make them 3 and 3. Initially they are 5-1, so you can make them 3 and 3, and the others won't change. Actually the others won't change, just that these two will become 3 and 3, and therefore it is satisfied. Correct? So yeah, either left or right. So either to the right you find a b such that their sum is less than 2k minus 2 or 2k minus 1, or to the left you can find a b whose sum is less than 2k minus 1. So basically, if you find a component of B's whose size is x2 and this size is x1, and if x1 plus x2 is less than or equal to 2k minus 2, then you can simply reshuffle them. You can reshuffle them and break them into components of k minus 1 and k minus 1 in the worst case. Like if they are k, if it is 2k minus 2, then you can break it into k minus 1 and k minus 1, right? So this was the case where you have only one problematic component. Okay, so in that case, I'll just give a summary. In that case, first of all, if the size of that one component, if it is greater than 2k minus 2 or greater than equal to 2k minus 1, then the answer is no. Then if it is basically otherwise, if, so now it is less than equal to 2k minus 2, right? So if you have a multiple g, if there exist a multiple g's, like multiple g, what does it mean? It means that there's a component having greater than 1 g, like either 2 g's, 3 g's, 4 g's, etc. Then the answer is yes. All right. Or if there exists a component of B such that its size is x2, and let's say this is equal to x1, the current is equal to x1, and x1 plus x2, if it is less than equal to 2k minus 2, then the answer is yes. And if all of them don't satisfy, like if either of these are not there, then you cannot make it. So the answer is no. Okay. Pratik is asking, but what about second class sample test case? How will you handle such cases? So we have BBBB, GBBB. So BBBB, GBBB. So Pratik, you are saying that on, yeah, K is equal to 4, right? K is equal to 4. So yeah. So in this case, there's only one problematic solution. There's only one problematic B, right? So you will check that is its size greater than equal to 2k minus 2 or greater than 2k minus 2. So what is 2k minus 2? It is 6. So size is not greater than 6. So the first test, like we don't print no right now. Okay. Then if there are multiple g's, then we print yes. But there are not multiple g's. There's only a single g right here. So we don't print yes. And if there is another component of b's such that the sum of their sizes is less than equal to 2k minus 2, then the answer is yes. So here x1 is 4, and if we take this component of b, then the x2 is 3, but the sum of their sizes is 7, which is greater than 2k minus 2. Like this is 6, right? So they don't satisfy this condition, so we cannot print yes. Like there is no other component of b which satisfies these conditions, so the answer is no. Pratik, is it clear? Like my algorithm was, I think, correct only. So what's your doubt actually? I don't understand. But okay, anyways, is it clear now? Just tell me that. Okay. So yeah, this was a solution where what I just did, I just broke these strings into the components, right? And I just checked that how many problematic components are there. Correct. So if there are more than 3, then we print no. If there are no components problematic, then we print yes. If there are two, then we would have to partition them. Like we would have to partition through them, the both the partitions through them. And if we have one, then one partition would be through them, and the other one can be from the same letter or from the opposite letter. Okay. So yeah, the solution is like this, and I think you should all have understood. Can you repeat 2k minus 2? Okay, so what I am just saying is that you want to break a component, right? What you can do is, let's say you have a component of b b b b b b, and your k is 2. Your k is 2, and you have one component which is like this. So what you can do is you can break it by placing a partition. But actually the thing is that this component is too large. Like initially the size is 6, right? The size is 6. So even if you break it into, let's say, half and half, 3 and 3, then also the the two components that you make, the three BBB, let's say there is G here, and BBB, the two components that you make here, they are also too large. Like, so it is not possible to not possible to break this component into two components because this is too large. And what do I mean by too large? Like, how large is too large? So how do we calculate that? So the thing is that, okay, let's say that initial size is x, right? Initially there are x b's. Let's say if there are x b's initially, we want to break it into x1 plus x2. Like I want to break x into x1 plus x2. Like the size of one component is x1 and other one is x2, where they both are less than k. So therefore, what can be the maximum? The maximum can be that x1 is k minus 1 and x2 is k minus 1. So in that case, the value of x in the maximum case is 2k minus 2. So if we have x greater than 2k minus 2, then we definitely cannot break x into x1 plus x2 such that their sizes are both less than k. So do you get this part? Yes. Okay. All right. So I'll move on to the code now, and the code for it is also pretty caseworky. Like this entire problem is just casework, and like I felt the contest was pretty unbalanced. Like this next problem was very tough, but till here it was just casework. So this contest was pretty good for me actually, because I solved I solved these two problems in div 1 very fast. And but I couldn't solve this, but still I got a very good rank because I solved it very fast, and no one was able to solve this problem. Like very few people were able to solve this problem, so I got a good rank. But anyways, the contest was pretty not satisfactory, like unbalanced, I would say. Yeah. Anyways, so what I did was I just broke this into components, and to do that, I am just taking the input of string s, and I am inserting a character which is not there in the string s. Like I am inserting a random character at the starting of the string, and this v vector is that the size of my components. Like for example, if my string is b b b g b g g, let's say the string is this, then my vector v would become 3 uh, sorry 3 1 1 2. So 3 1 1 and 2. So that's what I'm making in the vector v. Okay, so for int I equal to 1, I less than equal to n, I plus plus, if s of I is not equal to s of I minus 1, then I am doing v dot pushback 1. Like basically I am creating a new component of size 1. because the current letter is not equal to the previous letter. And if it is equal to the previous letter, then I'm just increasing the size of the last component. I'm doing v dot back plus plus, so I'm increasing the size of last component. Okay. Then I have a new vector which is called id. And what is this id? Id is the uh, number of the positions of all the components which have size greater than equal to k. Okay. And yeah, first of all, edge case, that if v dot size is equal to 1, like if the entire string consists of only one component, like let's say all b's, then this is also an edge case. So I just handled it right here, that if n is less than k, then the answer is yes, otherwise the answer is no. Okay. And yeah, then I make this vector id. Id contains all of the indices in the vector v. Okay. In the vector v, all of the indices which have the value greater than equal to k. Okay. So I'm doing for int I equal to 0, I less than v dot size I plus plus. If v of I greater than equal to k, then id dot pushback I. So if id dot size is greater than 2, then I print no and return. Right, the first case. Then if id dot size is equal to 0, then I print yes and return. Second case, right? And the third case, that if, so actually here I handled id dot size equal to 1 first, but before that I'll show you id dot size equal to 2. Yeah, um, so this code is for when there are two components. Okay. So first I am checking that if they have same parity or not. Like the index of the first block and second block, is that same or not? So what do I mean by that? Why did I do that? Like what I'm doing is, see, let's say I have two components which are greater than k. So let's say k is 3, and I have a vector which is 2 2 1 3 4, or not. Okay, let's say 2 and 4. So let's say this is my vector v. So how do I know? Like there are two indices, right? There are two indices which are greater than 3, greater than equal to 3, I mean. So how do I know that are they of same type or different type? So the thing is that if they are both even, like if they are both on even positions or they are both on odd positions, then they would have then they would have then they are on the same, of the same type. Like why? Because let's say that it starts with, let's say that the string starts with b. Okay, so this two component would be of b, then this two component would be of g, then this one component would be of b, and so on. So the components are alternating, right? So bg bg bg. So if they are on the same parity, then either they are both g or they are both b. So that's what I'm checking, that if id of 0 is odd, is equal to id of 1 is odd. So if both are even or both are odd, then this will be true. Like this entire thing will be true if both have same parity. So I'll return no in that case. Like I'll print no, because that is with the condition, right? And otherwise, if the size of both of them is less than 2k minus 1, then I print yes, else I print no. So that's the case for 2. Like the number of components which are problematic is equal to 2, then that's the case for that. And if it is equal to 1, if it is equal to 1, then that's what I have done here. Um, from here to here, if the size is 1, if id dot size is 1, where id is the all the indices which are problematic. So what I am doing is, first of all I am searching for what I am searching for a g. Okay, actually one more thing that I forgot to tell you, that take this test case. In the samples also there is this one test case. They take this one, b b b b g b b b g. Okay, so b b b b g and b b b g. So here, and k is 4, right? K is equal to 4. So actually, the thing is that this is problematic, and it is the only one. So what can we do? So in my algorithm, what I'm saying is, if there are multiple G's, then the answer is yes. And if there is a B whose size satisfies x1 plus x2 is less than or equal to 2k minus 2, then the answer is yes. Otherwise, the answer is no. But actually, in this case, the answer is yes, even though my algorithm says no. And why is that? Because I did not take into account this condition. Like, if G is at the end, like if there is one G at the end point, okay, then actually what we can do is we can simply reverse this subarray. Like, we can make a partition right here and one partition right here. So generally, if there was some component of B also here, then this would not work, right? Or maybe it would get deducted that there's a B, there are two B's here and four B's here, so the answer is yes. But in this case, it would give wrong answer, since you also have to check that if G is last one, like if we have a G on the last index, then we can simply reverse this entire subarray, and it would become B B B G B B B G and B. So this is actually the string that we can make. So yeah, there's one more condition that I forgot to tell you, that if multiple G's is yes, multiple G's then yes. If G at endpoint, then we have yes. And if this also, then also we have yes, right? So yeah, what I'm doing in the code is that um, I'm iterating over all of the indices of G. Like, what I have done is that, let's say my problematic index was id of 0, right? It was id of 0. So let's say it was even, then I will check all of the odd indices, right? I will check all of the odd indices because they are the opposite ones. Like, if I am currently at B and B is at even, then the odd ones will contain G. So I'll check all of them if they are greater than 1 or not. So if it is greater than 1, then I'll call it true. Or if they are the endpoint, like if they are 0, or if they are v dot size minus 1, then also I will say that it is true, flag is true. Like, it is possible to make the chef happy. So like, what I have just done here is int I equals to 1 plus id of 0 mod 2. So if id is odd, then this will be 0, and if id is even, then this will be 1. So it works out perfectly, and like I is less than v dot size, I plus equals to 2. So if id of 0 is odd, then I'm iterating over all the even numbers, and if id of 0 is even, then I'm iterating over all the odd indices and checking for this condition. If size is greater than 1, that is there are multiple G's, or it is the endpoint, that is G's are endpoint. So I do flag equals to true. Okay. Then also I'll check that is the size greater than equal to 2k minus 1. Like, if the size is too large, then of course I'll return no, right? So either flag can become true here, or I have to check the second condition also, that x1 plus x2 is less than or equal to 2k minus 2. Like, if I can find another b such that their sum of size is less than or equal to 2k minus 2, then also flag equals to true. So what I'm doing is, if I is odd, then I'm iterating over all the odd indices. If id of 0, if id of 0 is odd, then I'm iterating over all of the odd indices. And if id of 0 is even, then I'm iterating over all of the even indices. And what I'm just doing is int I equal to id of 0 mod 2, I less than v dot size, I plus equals to 2. So if v of id of 0, that is the size of this component, plus size of I is less than 2k minus 1, then we can just shuffle those characters in the same type, and we can satisfy it. So flag equals to true and break. Flag equals to true and break. Right. So if here also flag did not become true, and here also flag did not become true, then then we print no. Otherwise, we print yes. Okay, so this is the code. So yeah, this was the entire solution to this problem, and I hope you understood the code and my logic as well, including the proofs and my deductions. So yeah, well, thank you, Joe Trades, for your comments. I'm new to CP and new to CodeChef in general, but is the your CodeChef, the distribution is weird. If less than 10 people something, there are two problems. Actually, no. Like usually the CodeChef is not this unbalanced. Like if you see the last contest, or maybe you see CodeChef Starters 180, then in that it is not very unbalanced. So like you can see 215, 182, 113, 49, and 9. So it is decreasing, and in like a stable order it is decreasing. So yeah, that's the thing, that it is not unbalanced every time, but sometimes it might come like that, and today was one of those times, and which was how I became 6 star today. Like I solved these two and I solved this one very fast, so my rank was pretty good. uh, Not three, not I don't think it is third rank. I think it is updating right now, but my rank was around 15 in div 1. So yeah, anyways. So yeah, I hope you all understood this PCD. And if you still have any doubt in any of the four problems, then I am here to help you. So please comment if you have a doubt. Like right now, you can ask me in the live chat if you have a doubt. So thank you, Joe Trades, if that's your name. Okay. Anyways, so I think no one has a doubt now. So I'll take your leave, and thanks for joining in. Bye bye.